told at the beginning, it's so important to be careful how we handle these very sensitive, newly created nanolayers. So at this moment, when you take out the water, usually your copper plates stay shiny metal color until they are covered with caustic. And immediately as you remove the solution of caustic, the color starts to change in minutes.
Yeah, your nanolayers begin forming straight away. So it's very important to be very careful how you handle. Okay, so now during this early stage, once you've drained out your caustic liquid, one needs to take a multimeter and drain the voltage from the plates. And the best is to take 2 of your electrodes and do an opposite diagonal corners of your plate. You just hold for a couple of seconds. And if you do this every 6 hours in your first 24 hours after you've drained your caustic liquid.
So why this is important? If you don't do this, the atoms which got in the previous process in the form of a kind of gas around the plate will start to combine with the oxygen and will create those layers of, mainly made of copper oxide, and they create crystalline structures, exactly like the ice flowers are formed on your window when it is very cold outside, when it is frost outside, and you have some moisture inside a heated house. And you see how random shapes of crystals are creating, but if you wish to have a surface where to have a good energy flow, it's good to give a direction from one end to the other. And some voltage appears instantly on the surface of these wet parts, like plates or coils or wires or whatever you want to nanocoat. And when you unite with the wires of the voltmeter, you just allow that voltage to create a current through the measuring instrument and also through the surface of the plate in the space between the 2 contact points of your probes. And that very tiny current of the order of nanoamps or milliamps that will be enough to give an alignment of the crystalline structure which is getting to be formed into the new layers. So it's a procedure to align these layers.
Thanks, Sandor. I've got some
the multimeter has a positive and negative. Is it important each time you drain to use the same?
Let me say something. When you measure resistance, so you measure ohms, which you don't do it here, in that case, the multimeter applies the voltage of its internal battery, and always the red is positive and the black is negative. But in case, if you use the voltmeter, it doesn't matter, because the display will show plus or minus voltage. So it acts just very passively. It doesn't give a voltage from inside. It just creates a current between the voltage which you have already on the plate. So it really doesn't matter how you put positive and negative here. Your display will show in one direction, it will show let's say 65.9 volts or minus 65.9 volts like in the picture.
And to be clear, Sandor, it's the draining part that's important, not putting power into the plate. Some people think they have to put power into it somehow, but it's
the voltmeter doesn't put any power. If you would use the ohm meter, that would put power, but if you put power, then it will happen that the layers which are already formed will just pop out.
Yes, exactly. That's the way Mr. Kesh explained it at one point, is the layers tend to be too fluffy if there's power put into it. But if you drain the layers of power, then it tends to tighten up the nano layers and it makes them more effective.
So if you have no voltmeter, you just can use a set of wires and in between to put a resistor of high value, some mega ohms. That would do the same job, but it's better that you see and you are conscious about something happens there. So that's why it's better to use a voltmeter. But in case of limited technical possibilities, you can still make a nanocoating without a voltmeter, just with a piece of wire where you put in middle in series something of a high resistance. If you have no resistor of 10 mega ohms, for instance, you just can cut a stem from a branch of a tree and you take off its cork and you just twist the wires at their ends, and that will still give that limitation of current. So you can improvise whatever you don't have.
Yeah. It's a great way. All right.
Sorry for too much explanations. We don't
No,
want to overcharge the presentation.
It's important because this is such a crucial part of the whole process. So that's why I haven't put anything else for today's just this nano, because I knew it would take a while.
So I've noticed it on my voltmeter that often the first couple of drainings, I get a lot of action, and then towards the latter parts, the sixth or the seventh drainage, there's hardly any register on the meter.
So it depends how much moist you have around. If it's completely dry, probably the voltage which you observe will be less and less.
Oh, good, thank you.
So here's just a nice illustration of just a clip from the video of the importance of stabilizing and realigning your nano layers that are forming. Because what we're wanting to do is to sort of align and establish a line of flow through the nano layers, and we do this with the two electrodes, so we can dictate the flow through of our nano layers that we are wanting. And these are lovely photographs, pictures from Sandor, where it's just showing you that if we don't align wire, what our nanolayers would look like, so they'd be all over the place, so that we wouldn't get a very good flow coming through. Whereas if we do align them, we're now forming a nice flow, a nice even sort of flow of the nanolayers, so that when we do pass current through it, it goes through so much better. And the same when one looks at the top picture there with your plates. The red one is if we don't align, and then if we, on the blue one is if we do align at the two diagonal opposite ends. We're just creating, we're sort of dictating that flow that we are wanting. And this becomes very important when we're producing the coils for the MagRav units, because you're wanting to dictate the flow of electricity through your coils. So it's very important to know which ones where your electricity is going to be flowing through, in which direction.
So when we're doing plates, the positions of the electrodes, the tips of the meter, there in the structure, it's showing the opposite corners. One video, somebody did the upper and the mesh, or the two upper corners. Is there any one way better than the other?
So if you put on the upper corners, in that case, this will be the way of your flow of electric current. So you get a more uniform surface if you use the longest track. In case of a square plate, it will be the corners. In case of a wire, of course, it will be always the two ends.
And what happens if you use like the upper corner in the red, like you have it there, but the black is on the chicken wire mesh?
So you have here the chicken wire mesh. I'm drawing on the left side. And if you apply here, somewhere the one pole of the voltmeter, you have here the voltmeter, and you have here the other pole. So in that case, probably you will have something with this direction.
Well, if the plate is touching the mesh, will that influence no matter where you put the electrodes?
So it matters where you put, because let me draw with the blue color. If you put this electrode here, in that case you will get something like this.
The thing is, one of the techniques that used to be used originally was to move the electrode over the whole plate in various spots and just leave it on for a few seconds in each spot. So
Yeah,
you're removing the charge from the plate, you're taking charge off, you're draining. You want to drain the plate as much as possible, as well as align the fields like this. So
that has a special purpose in case you want to make GaNs production. In that case, you may want a higher spectrum or a higher range of the fields. So if you put your voltmeter at different random positions, you make one layer like this. If you use this point A and B, after 4 or 5 hours, you use these 2 points, for instance, C and D. So the next layers will be aligned in this way. So we'll have a mixture of layers of various directions. When you make the next one between this E and F, then it will come aligned in this way. So we'll have a mixture of directions of the layers, which is very good if you want to make a higher spectrum of fields in case of production of GaNs. But in case of energy production, sometimes it's better to have just a uniform flow. Or if you want to make a nano-coating for internal part of hemispheres, for instance, in that case, you apply it just once here in the middle, once at the edge, and you apply it only once, and you leave it untouched for the future, because there you may have the purpose to have a very uniform layer. It depends on your purpose. So no method is wrong, but different methods have different effects and different applications, different purposes. But for the beginning, it's good to understand the process itself, and later you can learn some more complex things. It's like when you learn to play at piano. So first you learn such a musical scales, later you learn harmonies, and later you will start to play melodies, and later you start to compose your own music. So here also in process of learning, we keep a similar gradient. So first you learn how to make a nano-coating, then how to use that nano-coating, and later you go to create your own symphonies with your richer knowledge. For the beginning, it's good to keep it simpler for people who are learning newly, to not get confused with too much information at once.
But it does show you the importance of what you're trying to create and for what purpose. So that really comes into play when you're wanting to create complex and intricate devices, and you're wanting to dictate flows. We need to understand why and how.
It's important that learning is not just by listening and reading or watching, but also by doing it. So after you watch, it's very much advisable also to do your own practical applications and experiments, and you will actually learn from what you will do and what you will observe while doing. So when the knowledge adds up.
I think what you're saying there is very important, and Mr. Kesh has brought that up in several of the last teachings over the last couple of weeks, that we have to know what's going on, not just theory, but it's also important to have a beginning point. Some of us have problems that we start experimenting with new things before we even do our first experience.
But that's fine, because even sometimes you learn from your mistakes. I tend to learn more from my mistakes than when you get it right. So that's why you have to practice. You have to play around and do it, because you learn from the whole process. And say there are no mistakes. It's just done differently, and you can learn a lot from that. So don't be shy in playing.
For sure, I would like to say there are no failures. So learning is achieved by a succession of successful and unsuccessful trials or experiments or life experience. You do something and the result is as you wished. In that case, you will repeat that. You do something and the result, it will be not what you wished. In that case, you don't repeat that way. So I used to say you cannot learn to swim without swallowing some water.
Okay, so once you've completed your draining, always put the lid back on, never leave your lid open. And so we drain the voltage to polarize the surface and dictate the direction of formation of your nanostructures. And so you can do this, as Sandor has shown, in different positions, or you keep your one position where you're putting your electrodes all the time. And then you keep your lid closed for a minimum of 2 weeks.
Let me quote, I don't remember who told this first, but somebody from the first knowledge seekers told once that growing nanolayers, it's like growing mushrooms. You need a lot of patience and care.
It's a good analogy.
So what is happening during these 2 weeks?
Well, during this drying process, the nanoparticles will be finding their position in respect to each other. So you are draining and you're dictating a certain direction, but because they are still wet, they are still moving, they're still positioning, like two little magnets. They've got to find their position in relation to each other. And that's basically what is happening during this process.
How often do you drain during that 2-week period?
Depends on your purpose. If you want to make plates for making GANs, you can repeat that 4 or 5 times each day. If you want to make something for energy, by my knowledge, and please correct me if I'm wrong, you do it once and never more. I'd like to add here something, just a little small drawing here. So if you have here the surface of your copper, and if you have here the atoms in a tight bond, in a metallic bond, as you have underneath, Then you make your first layer. Some small particles, atoms, are getting an extra energy due to the hot action of the hot sodium. And like when you melt a piece of ice or a piece of metal, first it goes from solid to liquid, and then it goes in form of gas. So here also we have something like a gas, which is separated from the original plate, but you have a field interaction between these atoms, these copper atoms which are free in a gas state, and between the atoms which are inside. So you have here an attraction, you have a repulsion, and also you have an attraction and repulsion between each. So they find a new position. They want to go a bit further because they got extra energy, but they cannot go too far because of the gravitational forces, the attracting forces. Once you made this, your first layer, and this is arranged, by the way, this gets completed by some oxygen also goes and becomes part of your structure. The copper atoms create some gaps and holes in between where, for instance, the oxygen from the water can fit into. So that's how you get a structure of oxygen atoms and copper atoms. Just I choose randomly another color. Color doesn't mean anything, just a different kind of element. And then you have such a bonds in between. And still there will be some spacing in between. So this to understand how this layering is created. And what's important, once you have your first layer here created, this is your first layer. So now the forces between this first layer and what's inside will pull out more atoms from underneath, and it will pop up another layer. And these created layers also will exert some force over the atoms which are inside the copper, and it will pop up more and more and more layers. So it's literally like when you make popcorn. When you see your nano-coated surface of black color, it means already you have here not 2, not 3, but you have here about tens of thousands of layers of an atomic dimension, of an atomic thickness. So you get about 40, 50 thousands of layers when the color appears black. When you don't see a color change, it doesn't mean you have no nanolayers. You have, but they are so thin that they are transparent. So in order to have a solid, such a thick layering, you need that time, those minimum 2 weeks and sometimes 2 months. So more time you let for these layers to get conditioned or created, you'll have a more stable nanolayer, which you will find the difference when you are producing ants and you put them into the into the salty water. You will see that some layers will not last too much and some will last for a very long time. It depends how you created them. So for a good job, you have to afford time.
Thanks, Sandor. I think the key here is patience. And we have to really take our time in creating these layers. So as Sandor said, after 2 weeks, or even ideal 2 months, one can then open the container lid, leaving a small opening. This is important because that change from the caustic environment in the container to the outside environment needs to be gradual. So when you're wanting to stop the process, then you need to at least do this 2 or 3 days beforehand, just by opening that lid slightly and allowing that gradual change of transition from one environment to another. So as Sander was drawing there, what we've done is we've taken through the heat, we've taken your copper, and we've created the nano layers. And so that black that we create, that's 10, 20, 30,000 layers of little balls on top of each other. So those are all your individual layers that one has created. And the importance with these layers then is, as you're creating in that direction, you've got superconductor in that flow, because you've now, with your draining, you've positioned your nanoparticles in a certain direction so that the flow is greater. And then in the opposite direction, you've created that super insulator. So that's why it's so important to take time in doing and creating your nano layers. It's not something that can be done in a weekend. And especially for coils, always hang them, never leave them flat. Even when you're storing your coils for later use, always keep them hanging, because even lying them down, the weight of that copper is going to damage the nano layers at the bottom of your coils. You see how delicate these layers are, so always hang when you're storing.
So preferably don't touch them like on the photo. So this was made for the sake of the photo, and when you process, you just use something to hook up the ends of the coils, and you leave it hanging and free without touching anything.
And then washing, it's just, when you finish that process, it's just carefully hold the plates from the corners and just rinse them gently with some distilled water. And please, particularly when you're going to be using them for GANS production, is to please wash all that caustic off your plates before using them in that GANS production. Otherwise, you're going to introduce the caustic into your GANS. So they must be washed before use.
Do you wash them with a cloth, or gently with a cloth or anything?
No, you don't touch it, you just rinse it. The water will not damage it, it's very soft.
And some people have suggested putting just a little bit of citric acid into the distilled water. Is that?
It's possible, but only a very tiny amount, and not in the last water. So it's always good to rinse it in 3 or 4 different waters, one after the other. So the water actually dilutes that salts or the caustic soda which is on the surface, and if you wash it in one water, that water will be already a very diluted solution of caustic. So I say you can rinse it first in simple clean distilled water, then in a second container you can add a few drops of lemon juice, for instance, to be sure you neutralize that the thing. But when you neutralize it also, it's producing some salts, and you want to get rid of those salts as well. So it has to be followed by rinsing in another clean water, and again into the next one. So how many times you can rinse how many plates in a water, that eventually you can measure it by titration, if you want to be very much like a technician of chemistry laboratory, but you have to you can just simply follow your intuition and understand that if you wash, let's say, 5 plates into 3 liters of water, it will be a cleaner water than if you wash 50 plates in the same quantity of water. Just rinse it, and rinse it. You have probably no running water of distilled water because it's expensive, but you can put 3 or 4 trays with some distilled water. So rinse in first, rinse in second, rinse in third, rinse in fourth, and then put into the container where you want to store them. If you have ever seen such a photo laboratory where they are developing the photographs, it was in fashion in the 70s, and in the 80s it was less and less, so later we use now digital photography. But if you have seen such a lab, you see that they put the exposed photographic paper into a chemical, then they wash it, they put in a second chemical, they wash it, they rinse it again, they put it into the third, and then they put it into a final wash to remove all the leftovers of the chemical. So here we use the similar technique. So you have some trays or bowls or boxes with clean water, and you rinse in first, rinse in second, rinse in third, eventually in the fourth, and you can deem that it's enough clean. You put it in and you move it back and forth for 2-3 times to let water flow on it, and then you take it out and you put it into the final box where you store.
And if it's not cleaned properly and you use it?
So how you know it's clean properly or not? So best thing is if you can measure it, for instance. As I said, there are methods. One is to measure the pH of the last rinsing water, which is not so accurate, and the most accurate is to use a titration. So measuring the pH could be enough good method for laboratory condition. But usually you don't have such expensive equipment, so you just keep rinsing several times in clean water, and that will be fine.
No, my
So
question.
Excuse me, the rinse distilled water or a filtered water?
So it depends how you filter it, because some water filters for drinking water, first they filter out all the dissolved solids and chemicals, and later they add some salts to make a better taste for the water, and you don't want those salts to get into your nano coating. So distilled water is the best, or deionized or demineralized water would be okay. It depends of your filtering, so what kind of filter you have.
Yes, well, we're using a Berkey water filter and not adding anything back into it. And our water is well water, so it's clean water, except probably it has minerals in it.
So you can get $10 worth of cheap TDS meter. TDS means total dissolved solids. And you can measure your clean water, how clean is. How much is the indicated total dissolved solids. If your instrument is calibrated well, you can trust that value. We tend to the perfection, but we never can reach perfect conditions.
I agree. I just, the amount of distilled water that I've purchased, the number of jugs that are around is just excessive.
Yeah, sometimes it happened to somebody to buy from a fuel station so-called distilled water, and when he measured it with a TDS meter, he found out that it has more minerals than his tap water. So you have to trust your source. Alternatively, you can build up your own distiller to distill your own water, so you can get distilled water at 50 cents per liter instead of paying $1 per liter. Or another alternative is if you live in a place where you have plenty of rain and the law doesn't forbid you to collect the rainwater, because we heard such a strange things in some states. In that case, you can harvest your clean water for a clean surface without bird droppings, eventually to filter it further, and that's the best distilled water which is distilled in the nature. Of course, you don't collect the water, the rainwater from the first 20-30 minutes of the rain, because also you have a lot of dust and smoke in the air, and that's washed with the first rain. But when it rains for at least 20-30 minutes, then you start to get a clean rainwater. So find out that which is suitable to your conditions and location.
My question was to point out, if you don't rinse your caustic plates or caustic off your plates and you use them for GANs, then what?
Wow, in that case, you will add that caustic which is sticking on the surface to your GANs, and that's an undesirable condition. Instead of having a pure GANs, you have a mixture of GANs and some caustic soda. So that's not advisable to use for health applications, for instance. You change the conditions with whatever you add to it. Whatever substances, elements you add into the process, those will be present at the end. So that's why it's good to have a separation, a purification at the end. Furthermore, when you create these nanolayers, you create a surface, the order of magnitude of dimension of the atoms, which has a lot of gaps and holes, and if you have caustic on it, those gaps and holes will be filled with sodium or the hydroxy radical or whatever, and the results will be not predictable.
Yes, thank you.
You're welcome.
Also note that it's important not to use your hands, even with gloves on, or a cloth or something like that, to wipe the plates off or try to get the caustic off that way. To just dip it or rinse it in the distilled water, correct? Jim, there's three people here with their hands up. I'm wondering if we're...
Yeah, we got quite a few people with questions here.
Take questions now, or do you want to continue with your
We just got, I think there's 1 or 2 slides to go, and then we open for questions. So
okay.
It will be better to leave the questions at the end, because otherwise we will never finish.
I knew this was going to be a long one.
Yeah.
Okay.
You were hoping for 1.5-hour workshops, right?
Yes.
I don't think
that's
so.
why I didn't even bring in GANs making into this one. I knew.
Well, this is good, though. A lot of really good information is coming out for people, and it's maybe a little. There's one complaint in the live stream that it's seeming a bit too advanced for the beginners, and most beginners won't want to even deal with this caustic business and so on. But you have to take into account, yes, there's some people that maybe shouldn't be doing this, but they can get other friends that just love doing this kind of thing to do the plates and so on for them. Or they can also buy the plates from the Keshe Foundation or other suppliers that are out there. So there are options for those that don't want to get their hands dirty, so to speak.
Yeah, this one we've had to go into the detail because it is such a crucial part of creating GANSs and any energy devices. So we've had to do the details so that you really, really understand how important this process is. We couldn't just skip it and dismiss it as just a quick step. People really need to understand how important this is. So that's why we have gone into the details.
Well, it's huge for health if you're giving it to clients or you're giving it to friends to drink or use. It's huge.
Yes, yeah. You've got to know what you're doing. Yeah.
And also one thing to consider is that during this entire process of forming the nanolayers, the environment of wherever you're making this nanocoating process affects the nanolayers, and so much so that even including your intentions affect the nanolayers. Your thoughts, your intentions, your reacting with the plates and everything create a different energy.
Okay, thanks, Flint. Storage. Sandor said this is also very important. Not to damage your layers that you have spent 2 months building and then just to throw them in a box. They have to be handled carefully and stored carefully until you need them. Try and store your plates upright and keep your coils hanging at all times, because they are as delicate as the little feathers there. And this was my pictures on my nano coating right in the beginning, so please don't do what I did. And you want to nano coat as many things as possible all at the same time, because now you are putting things on top of each other, so you're damaging the nano layers. And so please do not do what I have done and what many of us have done. You need to make sure that everything is separate and not touching each other, because you're just damaging the nano layers. And then there is an instructional video. If you go to the YouTube channel and go to the playlist of instructional videos, and there you will see video of nano coating there, as well as some information on the KF Wiki. And then just to finish off your list of materials again, I say it's important to, you see it's quite an involved process. You need to really have yourself prepared to know and have everything on hand before you even begin to start this process. So as a summary, you've got to be prepared and have everything organized, and safety is very, very paramount. So your hot caustic process, essentially 2 days, and then your drying, if you want to do your first 24 hours to align the layers with the multimeter, and as Sandor says, depending on what you're wanting to do, you can carry on with that aligning with the multimeter. You leave for a minimum 2 weeks to 2 months with the lid on, and it's only in your last 3 days where you'll open have a small opening with the lid to change that transition of the environment. And your plates must be rinsed with the distilled water. And then, as Flint brought up, your intention when this whole process is extremely important, as it will have an effect on your end result. And we will explain, and then you will have a better understanding as why this happens when we get into further workshops down the line in teaching on the soul. You will see why your intention is of utmost paramount. All right, so now we get to the good part, questions.
Okay, where to start here? Well, we do have some attendees with their hands up. I'll bring them in here. We have an Ed Stark. So, or sorry, Denny. Yes, Denny.
Hello, this is Denny. I have 2 questions. The first one deals with the chicken wire mesh. Why do I use chicken wire mesh? Why don't I use stainless steel mesh? What is the purpose of the chicken wire mesh?
So first purpose is to have a support for your copper parts at a distance from the solid caustic. Instead of using a chicken mesh, you can just make a support to hang them at a height some 2 centimeters higher than the level of your dry caustic. It's not a must to use the chicken mesh. So remember, whatever you put into your plastic box when you make the nano coating, so those elements will add to the coating.
Okay. I'm not going to disagree. I think there's a reason for the zinc-coated metal, but let's go on to the second question. Suppose I have never seen a multimeter in my life. What kind of settings, what am I really supposed to know about that multimeter?
Read the instruction manual or the user manual.
But then once I've used looked at the manual, how do I interpret what kind of setting I'm going to use when I'm touching the nano-coated plate?
Usually you go for 200 millivolts DC or 2000 millivolts DC or 2 volts DC. It depends of your instrument. You can start with 200 millivolts, which would mean the indication will be between 0 and 200 millivolts at maximum. And if it will indicate such a figure 1 on the left side, it means the voltage which you measure is over the range of 200 millivolts. In that case, you can change it to higher, to the next higher level, like a 2000 millivolts or 2 volts.
So I put my meter on a DC reading at 200 millivolts to start with.
DC and millivolts range. Usually the voltages which appear during this process can be of a few tenths of millivolts up to a few hundreds of millivolts. Sometimes it goes over 200 millivolts.
Okay, that's all I wanted to add. Thanks.
You're welcome.
Okay, we have an Ed Weatherall.
Yes, can you hear me okay?
Yes.
Okay. My questions revolve around the creating of the nano coating like a popcorn process. And Sandor mentioned the addition of the potassium was important because it's similar, it has some radiation, and it's that's important in like cell division. And that raised the question in my mind is, when we're making the nanolayers, are we causing a division in the copper atoms, or are we expanding the existing copper atoms to a larger, like the electrons are expanding to a larger?
You obtain the division from the molecular state, not a division of the atoms. You create a division in the molecular structure. You are not dividing the atoms at this process.
Okay, so each nano particle is created from an original existing copper particle.
Yes, so the copper particles from the surface of your copper piece will get an extra energy. So the electrons orbiting around the nucleus of those copper atoms will change to a new energy level.
Very good, thank you. My other thing I've always wondered is the copper is being exposed to a caustic steam, and that causes the heat and the reaction to cause this.
Sorry, not steam, liquid bath, immersion. There is another process which is nano-coating by steam, which we use it when we want to add an extra nano-coating on something which already has nanolayers on it. So don't confuse that the steam method with the hot caustic immersion method.
Okay, thank you. That answers another question I had. But so in the immersion method, it's the exposure to the caustic, and then okay, my question is, after the first layers, and I know you partially answered this, but when the first layers form, and they coat the copper, does that how do then the subsequent layers formed? I know you talked about the field forces of the nanolayers. Is that what is causing it? Because
Yes.
when the first nanolayers form, there is no more exposure directly to the caustic environment of the underlying copper.
Yeah, still you have a little moisture of caustic. So still you have some sodium present. And you have the first layers which have been popped out. And that makes a pulling force, and it gives also some extra energy to the atoms which are still into the metallic bond. So more layers of atoms can get freed. So these layers are growing from the bottom up, and not from, they are not growing as a layer on the surface and another external layer, but the first layer will pop higher, and then the second layer will follow it, then the third layer will follow it from underneath.
Really?
Yeah.
Okay.
This is what is done in those 2 weeks or 2 months of so-called drying, which is not really drying. Drying is just the last 3 days. I prefer to call it conditioning.
Okay, so just to be, I always envisioned the subsequent layers, the underlying copper atoms, when they were freed, moving through the gaps of the nanolayers to reposition themselves above because of some of the diagrams.
Not really, not going through the gaps, but they pop up between the first layer and the metal plate. Or the
So they form underneath the first layer.
Yeah, a nice animation would help very much to understand that process. So, but we have time being limited abilities to do such animations unless we get more volunteers who have such abilities and the facilities to make more animations, and we could cooperate to make more educational animations.
Okay, thank you. That's very helpful for my understanding. My last question is regarding nano-layering by a different process. Do we want to address that, or shall we just wait on that?
So we already passed over the planned 1.5 hours.
Okay.
And that would be another subject, but just for your information, there are many procedures of creating these nanolayers. So one is with using gamma layers. This was one of the reasons Mr. Cash was suspected by Belgium authorities for being in possession of gamma radiation sources, and they put him on a terrorist list or whatever, because they didn't understand how was he able to make these nanolayers without using gamma rays. So that was in the old knowledge. Also, it's possible to use many other ways to make nanolayers, and there are methods which have a common denominator, that you add extra energy to the atoms of the surface.
I was particularly
you can use methods like with heat. You can create nanolayers by heat. You can create nanolayers by electric energy and so on. So there are several ways.
Well, I was particularly interested. We all know that when we hook up our MagRav units, that the wires begin to nanocoat themselves. And
Yeah, that's nanocoating by plasma, and that's the best.
yes, so is that going to be covered later?
Yes, probably.
Okay, thank you.
Not today.
No, not today.
How about reusing your caustic?
You can reuse it for different purposes. For instance, you can keep the old cold caustic. And this is a method which on January 3rd, 2017, Mr. Kesh explained to the Kesh Plasma Reactor Group meeting after 2 hours and 41 minutes from the beginning of the video. You can find that video on the YouTube channel of the Kesh Foundation Spaceship Institute. And in the factory, they use this used caustic for pre-treatment or cleaning of the new copper parts which are going to be nano-coated. So they put the copper parts, plates or coils or whatever, for a couple of hours into that cold caustic just before to do the nano-coating. So it doesn't make a nano-coating, but that caustic will clean up all the fat and grease which would be accidentally on the surface of the copper. Like, you know, you use an oven cleaner or a barbecue cleaner, which is basically a caustic solution, maybe a sodium hydroxide or a mixture of sodium and potassium hydroxide. It's a household cleaning, and you see it dissolves all the fat and grease. So same, this cold caustic can be used to clean your future copper parts which are going to be nano-coated. You put them into that cold caustic, you leave for a couple of hours, and immediately from there you put immediately into the hot caustic process. You don't let them on the air. It would be interesting how to recover the caustic from the liquid, but this is a challenge to some industries who are dealing with caustic. It's very difficult to take out all the water of the caustic once it is in solution, because the caustic itself, it's a hygroscopic, so it's attracting the moisture. So let that be a future subject.
Very good. One last question is the container. Here we're using plastic, but there is the option of stainless steel or glass.
Glass is basically attacked by caustic. So you see its surface will change, because glass is a mixture of some chemicals, and some of those chemicals are degraded in the presence of caustic, so glass is not suitable. Furthermore, with high temperature, the temperature shock, the glass may break, so we don't advise using any glass for that. The best is to use a plastic which is heat resistant, and one of these plastics is polypropylene, PP. You find that usually on the bottom of the boxes there is a recycling symbol with a triangle with number 5, if I remember well. But 5, it's for a group of plastics, and usually it's added there the letters PP, which means polypropylene. The boxes which are good for food, for put food into microwave, for instance, or for storing food, are usually made of polypropylene, but you have to check. Polypropylene will start changing its shape at about 120 centigrades. And it will melt at, let's say, 140 centigrades. And you have to understand, when you add hot water, boiling water to the caustic, that will increase its temperature suddenly. Depending on the concentration of the caustic, it can rise up to 105, 110, or 120, or 130 centigrades. You see, in the material safety data sheet for caustic, always it says, never dissolve it into the hot water, always in cold water, because it will produce extra heat. So that's for safety. But here, we need that extra heat. That extra heat is part of the process. So you use plastic which withstand that heat. Polypropylene, it's fine. And for storing the caustic, also you have to take care to store it into containers or bottles which withstand the caustic. And one it is polypropylene, and the other is HDPE, high density polyethylene. Never store it into PET bottles, like the Coke bottles or soft drink bottles, because in time, the caustic will find its way to leak out, and you don't want a caustic spill that you can put in danger your teeth or the pets and so on.
So don't put it back in your distilled water bottles.
I am putting back in my distilled water bottles, but I buying distilled water into HDPE bottles, polyethylene of high density. So it's no problem, but never put it back into the bottles which are made of PET. I could share my camera if the host would allow me to show the difference of those plastics, how they look like.
Yeah, go ahead.
So this is a PET bottle of distilled water. Oh, my exposure is set to nighttime. Sorry for that. Just I have to set it to the normal light. So this is a PET bottle. It's transparent one, and somewhere you can find the symbol here. It's a recycling symbol 1. You cannot see it well by camera, and under it is PET. This is not good for storing caustic. It will make a hole and it will leak. And this is the other kind of bottles I'm using, usually this one. This is HDPE. You see, it's a thicker, it's a stronger, it's a soft plastic, but enough hard. It's a symbol, it's 2, and it's written PEHD or HDPE. Where is that symbol? It's hard to read it, the camera won't focus on it. But this is suitable for caustic. And always put a label, if you put caustic on it, put a big label there, put a big danger mark, and all the things needed to don't do any accident by confusing what you have in that bottle. That's important too.
Also, earlier there was some, not earlier today, but I mean, in the last weeks and months, there was some talk about using crunched up aluminum balls to reanimate your caustic, and that's a big no-no. Correct?
So don't use aluminum in this process. I know people are using it because they have seen a nice video where somebody put pieces of aluminum and they like to copy what's more beautiful. So you have to understand, if you put aluminum into caustic, that will, what effect will have? First of all, it will produce a lot of hydrogen. So more aluminum in caustic, you will have more hydrogen, and you can reach to dangerous conditions. You don't want to blow up your garage or your home. And the second thing is aluminum will get embedded into the nanolayers, and when you use it for health, you don't want to have the fields of aluminum, because those can cause something which is well known as Alzheimer's disease. So the problem with aluminum, that in certain circumstances, along with potassium, it can create a field strength which is equal to the field strength of the zinc, and zinc is needed by the brain, but instead of taking the zinc, the brain or the nervous cells the neurons will take up such a aluminum combined with potassium, and that will not ensure the proper functioning. So stay away of using aluminum in your nanocoating, and if you use, you can use that the nanocoated things to create energy, but never for health applications.
And that goes to not using an aluminum pot or pan, or even a stainless steel pot or pan for nanocoating for health purposes.
So stainless steel, it's an iron which is combined with chromium, sometimes some nickel, but chromium basically, and whatever elements you put in touch with your hot caustic, those will go into your nanocoating. If you want something predictable, so please use the plastic that gives good results. Plastic, like polypropylene, is mainly made of carbon and hydrogen, and all these are very neutral, so you have no problems with it. Furthermore, some part of the carbon from that plastic container may build up into your nanolayers, which will create such a graphene, such a 5–7% of your nanocoating may contain the carbon structures, which is no problem. But you don't want to build in aluminum, chromium, or other metals.
Yes, thank you. Okay, moving on, we have Jalal. Did you have any questions, Jalal? Okay, perhaps he's busy. We have next here on the list. Were you done with your questions, Ed?
Yes.
Okay.
I had one was just raised after that last comment by Sander, but I'll allow other people to go first, please.
Okay, thank you. We have a Peter Heitzberg. Yes, do you have any questions, Peter?
Yes, I did. Thank you. My question is in regards to the 2-week to 2-month period for the nano layering. How important is the temperature of the space that the containers are in with the lid on? Does it need to stay a pretty constant temperature? And if so, what sort of temperature are we looking at?
So heat is an important part of the process. So now this can be a problem for those who have no heated space. So recently I got such a question from somebody who is living on an island somewhere on the Pacific Ocean, and it's winter and has no heating, and it has a temperature of 8 centigrades or something like that. So in that case, you can improvise a heat box to preserve that heat which was created by the boiling water. Just let me share a picture. So I advised for nano coating can use a big box, a cardboard box, a wooden box, does not matter, a box which is bigger than the plastic container. So here is a side view of a bigger box. You can fill it with some insulating material. For instance, just wrapped up newspapers, old newspapers. You put here around. You put inside your plastic box. You put in your caustic, your chicken mesh, your copper plates or copper coils which you want to nano coat. You fill in the hot water, the boiling water, then you put the lid. And then you put an extra layer of wrapped up papers, and then you close the lid. And this thermal insulation will help to keep up this temperature for more hours.
Or if you have one of those coolers, you know, that you normally would put cold drinks and ice in, if it's large enough, just set your box in that and close the lid.
Yeah, the idea is good, but don't forget those are usually insulated with polystyrene, which don't resist to high temperature. So it can melt, or it can liberate some gases which are not very pleasant ones. So you have to use a high temperature resistant insulator. If you have a mineral wool, that would be the best. But if you want to improvise on something which is at hand, then you just can wrap up some paper, like used newspapers, which you get virtually for free. And for the other processes, if you are in a cold place, for instance, gas creation, you have to know that processes are slower at lower temperature and are faster at high temperature. That includes evaporation of the water and the need to replenish with fresh distilled water. But if you are really in a cold place and you don't have, you have no possibilities to heat up all your house, in that case, you can make such a heat box. A box made of wood, for instance, you make such a ventilation holes to not overheat. So such a 40 by 50 centimeters by 70, 80 centimeters or whatever size is suitable for you. Then you can put some electric lamps, not LED lamps, but this normal heat producing lamps with filament, and you have to check the temperature with a thermometer to not overheat it, or eventually you can put a thermostat to automatically set your temperature. So you can overcome these conditions. If you know what are you following, you can find a method how to get over. Or you may laugh, but one of the cheapest ways how to create a constant higher temperature is that used by gardeners in the northern hemisphere when there are autumns, winters, and cold springs. They use the manure. So they have boxes where they put earth and they are growing the seedlings. And they put around a lot of cow manure or horse manure around, and that makes us, they put some straw. This is manure. They have a lid or something like foil, and this manure is going to make a biodegradation by fermentation by some microbes, and it's producing some heat and also some smell sometimes, and you don't want that smell. But if you are really in the middle of nothing and you have no wood, like the gentleman who was living on an island, and the wood to make fire is very expensive because it's imported, they have no wood to cut on that island, this would be one of the ways. If they have some cows or horses, he can get some manure and to make a heat box with manure even in his garden, and still we'll have here 15-20 centigrades. So such method of heating was used, for instance, by the Kyrgyz people hundreds of years ago. They made a palace of their king of wood, and this was the house, and they put a lot of horse manure around. Yes, it had a specific odor, but it was warm inside without making fire. So if you have such a knowledge, you can improvise, you can use methods for achieving what conditions you need. So this is not a recipe now to be followed by everybody, but those in special conditions in harsh environment can think about what can they use to get a proper temperature.
And what would be the proper temperature?
Such a room, normal, comfortable room temperature, around 20 centigrades is fine, or 25 centigrades is fine. If you are in a colder place, like in your garage out in the winter, you will see the process is not working with the same speed.
Great. Thank you very much.
You're welcome. But you can make such a heat insulated box if you are living in a cold place, and for your nano coating. So a cardboard box like in which you purchased your microwave or your refrigerator, your vacuum cleaner, or you just get a box from the somebody else's waste, and you can fill it with papers, and you put inside your box, plastic box in which you make the nano coating. That can provide a good insulation by the layers of air which are kept in between the wrapped paper pieces. Or if you want to be very professional and you can afford, you can make a double wall wooden box in which you have an insulating layer of mineral wool like that, which is used to put on the walls to make a heat insulation. I wouldn't recommend the polystyrene foam because that's not heat resistant.
I think we'll have time for one or two more questions.
Okay.
We will be covering nano again, so we'll have another opportunity for many questions for Sandor.
Yeah, we got tons of questions here.
Yeah,
in Facebook.
we'll be here all day.
Yeah, I see a comment from John Wells. Potassio no es solo K40, hay otros isótopos. It's in Spanish language. So yes, the value which you find in the periodic table of elements, usually it's an arithmetic average of the isotopes which are found within the same element. So for instance, you see copper, it shows a molar weight of 64 in the periodic table of elements, but actually you cannot find isotope 64 of copper. Usually you have isotope 63 and 65 in certain ratio, and the average is written on the table of elements, but it would be the subject. Isotopes would be another subject of another workshop. So this is important to know what is written down. It's an ideal figure, and in nature you don't find ideal figures. You find individual properties. You have to make the difference. So you see on elevators it's written it's suitable to lift up 5 persons or 350 kilograms, because they consider average weight of a man is 70 kilograms. Meanwhile, I'm 125 kilograms. So how many of me could fit into the same elevator? Same it happens when you work with elements, isotopes, and so on. So everyone is its own characteristics.
Sandor, good day.
Hello, Jala.
Good day, everyone. Sandor, how the best way to preserve the nano-coated plates, the reserve? What is the best way to reserve them?
So in order to store them for a longer time, always close them into closed plastic boxes with a little moisture.
What kind of moisture? Only water?
Water, not alcohol.
Can we put a little bit NaOH in it?
If you keep caustic, in that case, the process of growing will continue. But if you you finish the nano coating, you reach to the desired quality, in that case, you wash and remove all the caustic. In that case, that growing stops, and you don't want to add more caustic on it. You can, for instance, put a few drops, 1 milliliter of water on a paper tissue, and to put it into the same box, and that will maintain some moisture inside.